Part 2, Thermodynamics. First law of thermodynamics, the energy entering, listen carefully, the energy entering the system, thermodynamic system, in the form of heat is equal to the sum of the increase in the internal energy of the system and the energy leaving the system in the form of work done by the system on its surrounding. I am repeating, the energy entering the system in the form of heat is equal to the sum of the increase in the internal energy of the system and the energy leaving the system in the form of work done by the system on its surrounding. And it is based on the principle of conservation of energy. Very simple. Say diagrammatically, I have taken one system. Here the one system is there. Thermodynamic system. I am supplying the amount of heat Q. That's the energy. Heat energy I am supplying to the system. Then first part of this energy is utilized to increase the internal energy. And whatever the amount left after increasing the internal energy, amount left is Q minus U. That converts into the work done. So total is your Q is supplied heat energy, that is equal to U plus W, work done. Q is what? Q is the amount of heat energy which supplied to the system, and U is the increase in the internal energy, and W is the work. So that is based on that is the first law of thermodynamics. That is based on the principle of conservation of energy. In the differential form, we are writing wherever. Why differential form? Because that amount of heat energy and the change in the internal energy and the change in the work done is also varying, is not having constant. So the differential form, we are going to write dq is equal to du plus dw. That is the differential. This is the applicable form, applicable in most of the cases. Differential form, dq is equal to du plus dw. Because this is q, u and w are varying in nature, that's why we are using this differential form. And dq is equal to du plus, we have discussed dw is equal to p dv, work done. That is your first law of thermodynamics. Then comes to the different processes. In thermodynamics, different processes are there. Like number one, isothermal process. Isothermal process. Some process we have to remember its a meaning and the concept. What is the meaning of isothermal? Iso means constant, and thermal means temperature. So a thermodynamic system in which temperature remains constant. Temperature remains constant means other thermodynamic entity or the variables may change. P, V may change. No problem is there. Then this type of process is known as the isothermal process. Only condition is that temperature remains constant. Means temperature remains constant means T is constant. So wherever we are going to write the change in temperature, that will become 0. When T is constant, means Tt is equal to 0. That is the isothermal process. Number 2, second process, adiabatic process. a process in which pressure, volume, and temperature of the system may change. A thermodynamic process in which pressure, volume, and temperature change, but no exchange of heat energy between system and surrounding. That is the important point. Pressure, volume, and temperature may change, but there will be no exchange of heat energy between system and the surrounding. जो एनर्जी है उसका एक्सचेंज नहीं होगा. देयर इज नो क्वेश्चन ऑफ द एक्सचेंज ऑफ एनर्जी. राइट मीन्स यहां पर पी चेंज हो रहा है, वी भी चेंज होगा, टी भी चेंज होगा, तो क्या चीज नहीं होगा? क्यू इज इक्वल टू 0. शुड नॉट बी एक्सचेंज ऑफ हीट. हीट हम नहीं दे रहे हैं, एक्सचेंज ऑफ हीट नहीं हो रहा है. एक सिस्टम है जिसमें पूरा अमाउंट ऑफ हीट जो भी है, देयर इज नो क्वेश्चन ऑफ द एक्सचेंज ऑफ हीट. नो एक्सचेंज ऑफ हीट. राइट, दैट टाइप ऑफ सिस्टम इज नोन एज. Number 3, isochoric process. Iso, as I told you, means constant, and choric means volume. A thermodynamic system in which volume remains constant. Volume remains constant. Means V is constant and dV becomes 0. But pressure and temperature varies. ऐसा सिस्टम जिसमें वॉल्यूम कांस्टेंट रहेगा, दैट इज द मैंडेटरी, दैट इज द कंडीशन, बट प्रेशर एंड टेम्परेचर डज नॉट रिमेन कांस्टेंट, इट इज द वेरिएबल. फोर्थ वन, आइसोबैरिक. A thermodynamic system in which pressure, baric means pressure remains constant. Pressure remains constant. Means P is constant and change in pressure becomes 0. But volume and temperature varies. वॉल्यूम और टेम्परेचर तो वेरी कर सकता है, लेकिन प्रेशर रिमेन्स कांस्टेंट. दैट इज नोन एज द आइसोबैरिक प्रोसेस. देन कम्स साइक्लिक प्रोसेस. What is the meaning of cyclic process? It consists of, from the name it's very clear, cyclic. It consists of a series of changes which returns the system back to its initial state. ऐसा सिस्टम जिसमें सीरीज ऑफ चेंजेस होगा, और चेंज होने के बाद फिर वो रिटर्न हो जाएगा अपना ओरिजिनल या इनिशियल स्टेट में। जैसे मान लेते हैं यहाँ पर एक सिस्टम है जिसका कोऑर्डिनेट है P1, V1 एंड T1, इनिशियल कोऑर्डिनेट, थर्मोडायनामिक कोऑर्डिनेट। कुछ चेंज हुआ, प्रोसेस में चेंज हुआ, दूसरा एक इंटरमीडिएट स्टेज बना, सिस्टम बना। यहाँ पर इसका P2, V2, T2 सिस्टम हो गया। फिर कुछ और सीरीज ऑफ चेंजेस हुआ, यहाँ एक थर्ड स्टेज आया जहाँ पर इसका थर्मोडायनामिक यहाँ पर कोऑर्डिनेट हो गया P3, V3, T3। फिर कुछ ऐसा चेंज हुआ कि ये ओरिजिनल फिर पहुँच गया। हम आफ्टर डूइंग सम चेंजेस, some process, series of changes, then it reaches to again P1, V1, T1. Then we are going to say it is a cyclic process. इस तरह का प्रोसेस को बोलते हैं साइक्लिक प्रोसेस। प्रैक्टिकली it is also possible. We are going to discuss later on. Let's say example, etc. PV diagram or indicator diagram. This is also an important concept. PV diagram or indicator diagram. A graph diagram is indicator diagram or means graph. A graph representing the variation of pressure with the variation of volume is called the PV diagram or indicator diagram. Now, what should be the graph? Graph looks like this. I have drawn the graph. I'm drawing the graph. This y-axis and this is your x-axis. Y-axis we are taking the pressure and x-axis volume. And initially the in case of thermodynamic system, say here initial stage, say P1, V1 is the initial first coordinate, initial coordinate of pressure and volume. Here V1, here P1. Then what happens when the volume increases, pressure decreases. So this graph looks like to be like that. Like that. And the volume, as the volume increases, this way we are writing it expanding or expansion. Volume increases means expansion. Here it reaches the final stage. And at this final stage, say the P2, V2 are the coordinate. And we can make it clear like that. So this is the nature of the graph of the PV diagram in case of expansion. And the same, if we are going to compress the volume, then what happens? If the same diagram is there, if we are going to draw the graph between the compressing or compression, then what happens? This, in case of compression, then from this compression means what? Volume decreases. If the volume decreases, pressure increases. So arrow mark is in this way, and it remains the same. This is the nature of the graph in case of compression. Now from this graph, usually the question is being asked to find the work done. How to find the work done? Say this particular graph I am taking and we are going to find this for the work done. Again I am doing for the work done separately. Here I have taken P, V, and this is your for the expansion. So our purpose is to, for the expansion in this particular PV diagram. Now, how to find the work done? The point is that from the graph. So for finding the work done, what we have to do, we have to select a two very near point. Say here one point, another here point, and just do it like that. So if I am going to draw very narrow line, so it is very difficult to understand. So the magnified image I am going to draw. Say here one point I have taken and another point here. But you remember these 2 points are very much similar, very much close, and draw like that. If I am going to draw a very small line, then it is not possible to visible. So this strip, this looks like a strip. So this point I am going to write A, B, C and D. This is a strip, and here it is, say, the capital A and here capital B. C, I see better to give the another name. See already here, A, B, capital A, capital B, say E, and this is your F. Now just to see what is the exact thing, initial condition we have taken P1, V1, initial coordinate, and here it is P2, V2, right? So this is your P2 and this is your P1, and here also we can write the V2 and here it is V1. Now our purpose is to find the work done. First, if I am going to see what is the work done, for finding the work done, if we are going to multiply pressure and volume, we will get the work done. Here, for this particular strip, this is shaded, I am shading it, this is strip. If I am going to find the work done, we have to multiply this pressure and the volume. But if this strip is very similar, or you can say this strip is like that, these 2 points are very close, then this is just like rectangle. So to find the work done, small work done, what we have to do, the area of the strip, area of small strip under the PV graph, So area of that strip is your A, B, C, D. So length into breadth, we can write it like that, CD into CB, CD into CB. So that is your area. So CD into CB, that is in fact the area of small strip. So in short, we can say, if I am going to find the area, that is equal to the work done. How? That I told you, work done is pressure into volume. So total work done, integrating of the area of strip with proper limit, means what? ये इंटीग्रेट करने का मतलब क्या है? If we are going to find this small strip, if I am going to find a total work done, तो पूरा हमको ये यहाँ से यहाँ तक का एरिया निकालना होगा. So area under the PV graph if we are going to find the area under this PV graph, we can find the total work done. Then that particular area is your A, F, E, B. We can write it A, F, E, B. Whatever the shape may be of that particular shaded portion. We have to find the area, and after finding the area, that area is equal to the work done. That is also applicable in the numerical examples. Okay, in the next video